I want to introduce you to our team, Great Hackers. Here's Walter.
Hi.
Here's Jose. My name is Leo, and we're all students from UMass Amherst. So just want to talk to you a little bit about why we came to this project. So you guys know Hackathon is a 24-hour constant programming contest. And we seek out and really want to find a challenge for ourselves in these 24 hours. And we found in the 1980s, Mini Mover 5, given to UMass Amherst by GE, and we found that we couldn't interface with the technology, right? And we're really curious that what is a way that we could both interact with our little friend and still produce something usable for future applications. So, what better way to interact with technology with using your hands? So we've created a Arduino-powered arm with accelerometer, a robotic arm that can be controlled by your hand. Here's our little friend, Darlene. Darlene, say hello.
Hello, everybody. Do my best.
So Darlene is controlled directly by a accelerometer placed on the glove, and you can see there under the yellow tape. Also a force-sensitive resistor which can be pressed as the clamp. We really hope to bring this technology as an open source platform for people to use in terms of interacting with future older technologies, a direct way that you can provide an interface to new technology. The way we set up the older robotic arm was to actually look at the stepper motors themselves. So we created a brand new interface for the stepper motors, and we linked up our interface directly to it. I'll pass the next part to Jose to tell you a little bit about the mechanics behind the design.
Sure. Hi, I'm Jose. I study EE here at UMass. I'm trying not to break this thing while I talk. Whatever. Okay. So this thing is basically consisting of 6 stepper motors, each with 4 phases to rotate the motors. And what we needed to figure out was which sequence of the 4 wires we needed to set high. So we went through a number of stages of failed attempts and we still don't have the range set up, so we might break a line or two, but hopefully not. And that's essentially it. It was really just figuring out the sequence of these motors and just doing 6 of them in parallel. These guys wrote most of the code for it, and it is pretty complete.
So, anyone want to experience this glove? Try wearing it, try to control the technology.
You don't have much time for that.
Don't have much time? Can we have one volunteer?
Well,
awesome.
Okay.
Yeah.
All right, fire away. Sure. All right, sorry for your speech. Okay. This glove's kind of tight. Okay. Left hand.
Are there any questions while we're doing that?
Questions?
Did you try to use Bluetooth?
we got scared. We didn't like wireless. It makes us paranoid.
What are the gestures that you do?
The gestures are a x-axis upwards motion, downwards motion that pushes the arm up and down. Tiny tip up and down that controls the wrist, tilting it left and right that controls the wrist, and pressing on the force resistor to open and close.
How did you reverse engineer the arm?
Reverse
The output that
Press on the soft one.
Is your plate just the readings on your Arduino or what?
Yeah, we take the accelerometer reading and gyroscope for reading of the XYZ plane applications.
Yeah, you want to try and grab that? It's tight. Walter, you have to put in range.
So just now we're good. Now close it.
It's pretty powerful.
Okay, it's yours. We're locked in. All right.
You talk about integrating this with or something you can use like open source tool with other old technology, how would you apply what you did here to like other pieces of technology?
Well, think about interacting with any piece of technology, like a lot of groups have done, or is using a motion library as a trigger. So we actually set up a pretty great motion library that detects different axis movements. You can add in different, you can create optional gestures and use it to control great devices like this. And of course, open sourcing allows you to put this on your own device, create better guidelines for safer conditions. And it's a really, really simple interface. So we want to show that it doesn't have to be complicated for you to interact with technology this way. Cool. All right, thank you very much.